Hey everyone, welcome to Tech Talk Tuesday. I'm Emma, and I've been on this quest to find a better way to handle all these research papers. There's gotta be a more efficient way than spending hours manually copy-pasting from PDFs into my notes so I can feed them to LLMs, right? I'm super curious, Alex. At that hackathon you went to last month, did you come across anything that might help with document processing? My PhD supervisor keeps sending me these massive papers, and my current workflow is, well, not working.
Oh, Emma, you're going to love this. I'm Alex, and yes, I discovered exactly what you need. It's called MarkItDown, this versatile document conversion tool that transforms practically any format: PDFs, Word docs, HTML, even images with text into clean Markdown. And the best part, it preserves the structure, tables, formatting, headers, the whole deal. We've been using it at work, and our documentation pipeline went from taking hours to just minutes. It's like having a universal translator for all your document formats.
Ugh, I've been drowning in PDFs lately. Literally drowning. I spent the entire weekend trying to extract structured text from research papers so I could feed them into my language model. It was a nightmare of copy-pasting and manual formatting. There has to be a better way, right?
Oh, you need to check out MarkItDown. I discovered it at a hackathon last month, and it's been a game changer. It's basically this Python library that converts all kinds of documents, PDFs, Word files, web pages, into clean Markdown. That's perfect for feeding into LLMs.
Wait, seriously? That sounds too good to be true. How easy is it to use? Because I'm not looking to add another complicated tool to my already chaotic workflow.
Super straightforward. You just create a MarkItDown instance and call convert on your document. Like 3 lines of code, tops. It automatically figures out what type of document you're throwing at it and handles all the conversion magic behind the scenes. Our documentation processing went from hours of manual work to basically pressing a button.
That would save me so much time. But what about tables and figures? Those are always the worst to deal with. And some of my PDFs are scanned documents with terrible formatting.
That's where it really shines. It preserves table structures, handles images, and even has OCR capabilities for scanned docs. It's not perfect on super complex layouts, but it's honestly about 90% there. The real power is in its plugin ecosystem, though. You can extend it with custom converters if you have specific document types or formatting needs.
No way. So I could potentially create a custom converter for, those weird proprietary file formats my department uses? And wait, does this work with batch processing? I have folders with hundreds of papers.
Exactly, the plugin system is super flexible, and for your batch processing question, absolutely. You can run it locally for small batches, but they also have this MCP server integration for scaling up. We used to process about 500 documents weekly, took nearly a day. Now, 30 minutes, tops. The server handles all the heavy lifting, and you can configure processing pools to optimize for your specific hardware. I've seen research labs using it to feed their entire literature databases into custom LLMs to generate literature reviews and identify research gaps automatically.
So I've been playing around with the MarkItDown class in Python, and it's been super helpful for converting all my research papers into Markdown. But, I'm wondering, is there a way to use MarkItDown without having to write Python code every time? Sometimes I just need to quickly convert a document while I'm in the middle of something else.
Oh, absolutely. That's where the command line interface comes in. It's basically like a remote control for MarkItDown. Instead of opening up your Python editor, you can just type a simple command in your terminal. So if you've got a PDF that you need to convert, you just type markitdownexample.pdf and boom, instant markdown right in your terminal.
Wait, that's it? Just MarkItDown and the file name? That would save me so much time. I've been writing these little Python scripts for each batch of documents I process for my research. Oh, but what if I want to save the output instead of just seeing it in the terminal? I need to feed these documents to my LLM for analysis.
Yep, it's that simple. And for saving the output, you've got a couple of options. You can either use the redirect symbol, so markitdownexample.pdf, example.md, or use the output flag like markitdownexample.pdf, example.md. Our documentation team went from a 3-hour conversion process to about 10 minutes just by setting up a simple batch script with these commands. Perfect for feeding clean structured text into your LLM without all the PDF formatting mess.
That's exactly what I need. I've been losing my mind trying to clean up the formatting gibberish that comes from copy-pasting directly from PDFs into my LLM prompts. Tables are especially nightmarish. They just turn into this weird space-aligned text that the model can't understand properly. Does the CLI preserve structure like tables and lists too?
It absolutely does. The CLI uses the same core engine as the Python class, so all that structural preservation, tables, lists, headers, even some basic image descriptions, comes through beautifully. And here's a neat trick. If you're processing lots of files, you can use standard input like catexample.pdf, .nar, MarkItDown, or even combine it with other command line tools. I've seen researchers set up entire pipelines where they extract text from hundreds of papers, run it through MarkItDown, and then feed it directly to their LLM through an API. All automated, no human copying and pasting required.
No way. That would be a game changer for my literature review process. One last question. Sometimes my PDFs are really complex, with weird formatting, or they're actually scanned images of text. Does the command line version handle those cases too? Or do I need to go back to the Python class for more control?
Good question. The CLI actually supports all the same flags and options as the Python class. So if you've got a scanned document, you can add the OCR flag to enable optical character recognition. Or if you're not sure what type of file you're processing, like when you're reading from a CERT-in, you can use format PDF to give it a hint. We've even added some LLM-specific output formats like JSON for LLM that structures the content in a way that's optimized for large language models. It's pretty much the Swiss Army knife for document to LLM pipelines.
So I've been using the command line interface for MarkItDown, and it's honestly been a lifesaver. Like, I've processed about 50 research papers in the time it would have taken me to manually format just 5. But I'm curious, what's actually happening behind the scenes when I feed it a file? There must be some kind of, identification process?
You're absolutely right. There's this really cool component called Stream Info that's working invisibly every time you use MarkItDown. I actually discovered it when I was digging through the documentation after that hackathon. It's basically like the TSA of your document processing pipeline.
Wait, TSA? Like airport security? How does that work with my PDFs? I'm just imagining my documents going through those little scanner things now.
Haha, exactly. Think of Stream Info as an ID checker for your files. When you throw a document at MarkItDown, whether it's a PDF, Word doc, or whatever, Stream Info figures out what kind of file it is, what encoding it uses, where it came from, all that metadata. It's like when TSA looks at your passport and decides which security line to put you in.
Oh, so that's how it knows to treat my messy scanned PDFs differently from my nice clean HTML files. I always wondered why it seemed to just know what to do with different document types. This actually solves a huge problem for my research workflow. I need to feed all these different document types into my LLMs for analysis. But the models get so confused when the formatting is wrong.
Exactly. And what's really cool is how Stream Info builds up this profile gradually. Like maybe at first it only knows you've got a PDF, but then as it processes the file, it learns more, like the encoding or that it contains tables. We had this documentation pipeline at work where we were manually checking file types before processing. After implementing Stream Info, our error rate dropped by like 85% because we weren't trying to process PDFs with the HTML converter anymore.
That's huge. So in practical terms, if I'm building my own tool on top of MarkItDown for my research group, can I actually access this Stream Info data? Because it would be amazing if I could automatically route certain types of papers to specific analysis pipelines based on their characteristics.
Absolutely, that's one of my favorite parts. You can either create a Stream Info object directly in your code, super simple, just a few lines, or you can let MarkItDown generate it automatically and then access those properties. So your code could check, hey, is this a scanned PDF line, and then route it through an OCR step first, or you could see that it's already HTML and skip straight to semantic analysis. We've got teams using this to automatically process thousands of financial documents with different rules based on the document type.
So after talking about Stream Info, I'm really curious about this document converter class. I've been struggling with feeding all these research papers into my LLMs. Some are PDFs, some are Word docs, and don't even get me started on the scanned image PDFs. It's such a mess. Is Document Converter the thing that actually handles all these different formats?
Exactly. That's the beauty of it. Document Converter is basically this clever blueprint, technically an abstract base class, that standardizes how any document gets transformed into Markdown. Think of it as a universal recipe template. You know how every cooking recipe has sections like ingredients and steps? Document Converter ensures every converter in the system follows a consistent pattern, regardless if you're dealing with those pesky PDFs or Word docs.
Wait, so it's not actually doing the conversion itself? It's more like defining what a converter should be able to do? I've spent so many hours copy pasting from PDFs, trying to preserve formatting, and then cleaning up the text before I can feed it to my models. It's mind-numbing work.
You've got it. It's the template that says, hey, every converter needs to have these capabilities. Specifically, there are two essential methods: accepts, which determines if a converter can handle a particular file type, and convert, which does the actual transformation to Markdown. Before I found MarkItDown, our documentation pipeline took hours, manually converting, fixing formatting, checking tables. Now, I just pipe documents through the system and it automatically routes each file to the right converter. For your research papers, it would identify PDF files and send them to the PDF converter, which preserves all that structure you need.
No way. So I could just throw my entire literature review folder with all its mixed formats at this thing, and it would figure out what converter to use for each file? That would save me literally days of work. But what about those really complex papers with equations, tables, and figures? My models get so confused when those elements are all mashed together in plain text.
Absolutely. And that's where the beauty of the design comes in, because Document Converter is just a blueprint. The team has created specialized converters for different document types. The PDF converter actually preserves table structures, handles basic equations, and can even extract and reference images. One of our developers was working with financial reports, those PDF monstrosities with nested tables and footnotes everywhere, and reduced his pre-processing time from 3 hours to about 15 minutes. For your research papers, this means your LLMs get much cleaner, structured input to work with.
That sounds almost too good to be true. I've tried other converters before, and they always mess something up. How extensible is this system? Like, what if I have some really niche file format from a specific research database that isn't supported yet?
That's where it gets even better for researchers like you. Because of the Document Converter blueprint, adding support for new formats is surprisingly straightforward. You just create a new class that implements those two methods we talked about, accepts and convert, and the system automatically integrates it. We had a team in pharmaceutical research who created a custom converter for their proprietary lab report format in just a couple hours. And here's the cool part: they contributed it back to the plugin ecosystem, so now everyone benefits. I bet someone in your field might have already created converters for those niche research formats.
So, Alex, we were just talking about this document converter blueprint thing in MarkItDown, but I'm still struggling with all these different file formats. Like yesterday, I had to extract text from PDFs, Word docs, and even some Excel spreadsheets for my research dataset. I spent hours copy-pasting and fixing formatting. Please tell me MarkItDown has something for this specific nightmare?
Oh, you're going to love this part, Emma. Think of the document converter as the master blueprint, right? But then MarkItDown has these specialized converters built on top of it, sort of like having different translators for different languages. So instead of you manually figuring out how to handle PDFs versus Word docs, there's a specific converter for each format that knows exactly how to interpret that file type.
Wait, so you're saying I don't need separate tools for each format? What kinds of formats can it actually handle? Because my research database is basically a format zoo at this point.
Format zoo. I'm stealing that term. But yes, that's exactly the problem it solves. The library comes with converters for all the usual suspects: PDFs, Word documents, HTML, and plain text files. But what's really cool is it also handles trickier formats like Excel spreadsheets, PowerPoint presentations, images with text using OCR, and even EPUB files. Our documentation team used to have separate processing pipelines for each format. It was a nightmare to maintain.
No way. It can actually handle spreadsheets? That's been the bane of my existence with data extraction. But how does the system know which converter to use? Do I have to specify, hey, this is a PDF every time?
That's the elegant part. You don't. Each format-specific converter has this method called accepts that basically says, yep, I can handle this, or nope, not my job. It checks things like file extensions and MIME types automatically. So for PDFs, it looks for the .pdf extension or the application PDF MIME type. If it finds either one, that converter raises its hand saying, I got this one. You just throw your document at the library and it routes it to the right specialist.
That sounds almost too good to be true. So in my research workflow, I could just point it at a folder with mixed document types, and it would just figure it out. Because right now, I'm literally sorting files manually before processing them, and it's killing my productivity. My advisor keeps asking for results, and I'm like, still prepping the data, sorry?
Exactly. Our team went from spending days processing documentation in different formats to just running everything through a simple pipeline. The time savings are incredible. One client was manually extracting text from thousands of legal documents. Took them weeks. With MarkItDown, they set up a simple script that processed the entire archive overnight. And the best part for research like yours, since everything comes out as clean, consistent Markdown, it's perfect for feeding directly into LLMs for analysis. No more garbage in, garbage out problems with weird formatting confusing your models.
So, we've been talking about all these built-in converters for PDFs and Word docs. But what about those weird formats some of my professors insist on using? Like, I have this one advisor who still sends everything in RTF format, and I'm like, seriously? It's 2023.
Oh, that's where you're going to love the plugin system. Think of MarkItDown like your smartphone. It comes with built-in apps, right? But what makes it powerful is downloading new apps from the App Store. The plugin system works exactly the same way, yet you can extend MarkItDown to handle formats that aren't supported out of the box.
Wait, so I could actually get it to handle those annoying RTF files without waiting for the official developers to add support? That would be a game changer for my literature review process.
Exactly. You just find a community-created RTF plugin, install it alongside MarkItDown, and then enable plugins with a simple parameter. It's literally one line of code. Create your converter with enabled-wise plugins OSH true, and boom, you're converting RTF files just like any other format.
That sounds almost too easy. So how does it actually work behind the scenes? I'm guessing there is some clever engineering making this possible, right?
There is. It uses Python's entry points mechanism, which is, let me use an analogy. It's like a restaurant where the standard menu offers certain dishes. Those are your built-in converters. But then guest chefs, the plugins, can visit and add their special recipes without rebuilding the kitchen. When you enable plugins, MarkItDown basically looks around and says, hey, who else can cook here and registers all those extra chefs?
Oh, so when I'm feeding documents into my LLMs for analysis, I could potentially handle any format my research throws at me? That would save me so much time compared to my current copy-paste nightmare. How hard is it to actually implement this in my workflow? I'm good with code, but, time is precious when you're racing publication deadlines.
Super straightforward. You have two options. Either enable plugins right when you initialize MarkItDown with converter, yes, the MarkItDown, enable plugins swap a true, or you can enable them later if you want. After that, you just use the converter normally, result os converter.convert weird format.xyz, and it just works. We implemented this at my company, and our document processing pipeline went from manual conversion headaches to just dumping everything through MarkItDown into our LLM system. Tables, formatting, citations, all preserved.
So we were just talking about the plugin system for MarkItDown, which sounds super useful. But I'm curious about this URI processing thing that connects to it. Is that like how you actually feed different document types into the system?
Exactly. Think of URI processing as the universal adapter for MarkItDown. You know how in the kitchen you might have ingredients from your pantry, the grocery store, or maybe something someone handed you? No matter where they come from, you need to unwrap and prep them. That's what URI processing does for content, whether it's a file on your computer, a web page, or raw data embedded in a URI.
Oh, so it's like a standardized way to point to different content sources? I'm guessing URI stands for Uniform Resource Identifier, right? Like URLs for websites, but more universal because honestly, half my research workflow is just trying to get content from different places into a format my LLMs can actually use.
Spot on. URLs are actually just one type of URI. The whole system follows this format. Scheme, .scheme specific part, where the scheme tells MarkItDown what type of resource we're dealing with and how to access it. So file and for local files, HTTPS and for web content, even data for embedded information. MarkItDown sees all these different sources through the same lens.
Wait, so you're telling me I could feed MarkItDown a local PDF on my computer, a research paper on AR Creative, and some raw text data, all using the same approach? That would save me from the copy-paste nightmare I've been living. Laughs. I literally spent 3 hours last week just reformatting content from different sources for my experiment.
That's exactly the problem it solves. Last month, our team had this documentation project pulling content from our local knowledge base, some GitHub repos, and various websites. Instead of downloading everything manually, I wrote a simple script that fed different URIs to mark it down. The whole process went from being a multi-day headache to something that ran while I grabbed coffee. It was like file our documents, specs.pdf for local files, https github.com, our repo readme.md for web content, all through the same pipeline.
This sounds perfect for my research workflow. I'm always trying to feed documents into different LLMs for analysis. How does the system handle complex documents, though? Like if there are tables or weird formatting in PDFs, because that's usually where everything falls apart for me.
That's where the magic happens, honestly. The URI processor handles the fetching part, but then MarkItDown's conversion engine takes over. So tables get preserved as markdown tables, headings maintain their hierarchy, lists stay as lists. It's not 100% perfect, right? Especially with really complex layouts, but it's miles better than plain text extraction. And because everything comes out as clean, structured markdown, LLMs can actually understand the document organization instead of getting a wall of text. We've got users who set up complete pipelines where new documents automatically go through MarkItDown before hitting their GPT instance for summarization or analysis.
So we were just talking about how MarkItDown can handle content from all these different sources with that URI processing feature. But what I'm really curious about is how it actually works with LLMs. Like, I've got hundreds of research papers that I need to feed into models for analysis, and I'm spending half my life just trying to get them into a format the models can use properly.
Oh, this is actually where MarkItDown really shines. The LLM integration feature is basically like giving your document converter a pair of AI eyes. So instead of just converting the text, it can actually see and understand the images in your documents too.
Wait, seriously? So it could, like, automatically describe figures and charts? Because I can't tell you how many hours I've spent manually describing visualizations from papers so my models can understand what's in them. It's been a complete nightmare.
Exactly. That's the problem it solves. So imagine you've got this complex climate change infographic in your document. Without this feature, you'd just get a basic image reference in your Markdown. But with LLM integration enabled, MarkItDown will send that image to something like GPT-4 Vision, which generates a detailed description automatically. Well, it'll capture the temperature trends, emission data, everything, and add it right into your Markdown output.
That sounds almost too good to be true. How does it actually work behind the scenes? And please tell me it doesn't require some complex setup with a bunch of dependencies that'll take me a week to configure on the university's lockdown systems.
It's surprisingly straightforward. Under the hood, MarkItDown identifies all the images in your document, then sends each one to an LLM with vision capabilities, like GPT-4 Vision. The AI generates the description, and MarkItDown inserts it right into your Markdown. You do need an API client for whatever LLM service you're using, plus the appropriate API keys or credentials. But we've made the integration really plug and play. Most of my team had it running in under 5 minutes.
This could literally save me hundreds of hours. I'm working with this multi-institutional research project where we're trying to feed historical climate papers, some going back to the 1950s, with all these hand-drawn graphs, into our models. Do you have any examples of research teams using this in their workflows? I'm trying to imagine how I could convince my advisor this is worth implementing.
Absolutely. There's this computational biology lab at Stanford that was using it to process thousands of microscopy images from old papers. They went from spending about 20 hours per week on manual image descriptions to just running an overnight batch process. And the quality was actually better than their manual descriptions because the LLMs could pick up on subtle patterns in the images that humans might miss. It's become this essential bridge between messy real-world documents and clean LLM inputs. I've started calling it the missing link in document to LLM pipelines.
So, Alex, we were talking about LLM integration and how MarkItDown can describe images using AI. But I'm still copy-pasting things manually between my documents and the AI assistants I use. There's got to be a better way, right? I mean, I'm literally taking PDFs, converting them, then feeding them to Claude or other assistants. It's so tedious.
Oh, Emma, you're going to love this next part. There absolutely is a better way. Have you heard about the MCP server component? It's basically a bridge that lets AI assistants like Claude directly use MarkItDown's conversion powers without you having to do the middle steps. No more copy-paste nightmare.
Wait, MCP? What's that stand for? And are you telling me Claude could just process my PDFs directly? That sounds almost too good to be true.
It stands for Model Context Protocol. Think of it as giving AI assistants extra superpowers through specialized tools. See, while Claude is amazing at understanding text, it doesn't natively know how to convert a PDF or extract structured data from a Word doc. MCP server is it's like giving the AI a Swiss Army knife of new capabilities. So when you upload a PDF to Claude, behind the scenes, it can call Markdown through the MCP server and say, hey, convert this for me, and then work with the cleaned up Markdown.
Oh my God, that would save me hours every week. So could I actually see this in action? Like, what would the user experience look like? Would I notice anything different when talking to Claude?
It's pretty seamless from the user perspective. You just upload your research paper to Claude and say, I need this in Markdown format. Then Claude would respond with, I can help with that. And a few seconds later, bam, perfectly formatted Markdown. No visible conversion steps for you to worry about. Behind the scenes, Claude is using the MCP server to access MarkItDown, but all you see is the result. We've cut our documentation processing pipeline from hours to minutes with this setup.
That sounds incredible, but I'm guessing setting up this MCP server is super complicated. I'm still trying to manage my PhD research. I don't have time to become a server admin too.
It's actually surprisingly simple. The basic setup is just a few lines of Python code. You create an MCP server instance, register your MarkItDown conversion tool, and you're basically done. You can run it directly from the command line with something like Python and MarkItDown watch MCP for simple mode, or as an HTTP server with HTTP port 3001 if you need network access. I've got some grad students using this setup who had it running in under 15 minutes, and they're definitely not server experts. The real magic is in how it transforms your workflow once it's running.
So after setting up that MCP server we talked about, I tried throwing a bunch of my research PDFs at it. And, let's just say not everything went smoothly. Some of my more complex documents caused errors, and I had no idea how to handle them. Is there some way MarkItDown deals with these kinds of issues?
That's actually perfect timing. We were just about to discuss exception handling, which is basically the safety net for when things go wrong. You know, even the best document processing systems will encounter files they can't handle perfectly. Corrupted PDFs, weird formats, missing dependencies. The difference between a good tool and a great one is how gracefully it fails.
A safety net. That's a great way to think about it. So instead of my whole pipeline crashing when it hits one problematic document, it could, what? Give me an error message and continue with the next file? That would literally save me hours of debugging time.
Exactly. MarkItDown has this whole family of exceptions designed for different scenarios. There's the base exception class, and then more specific ones like missing dependency exception, which happens when, say, you're trying to convert a PDF but don't have the PDF processing library installed, or unsupported format exception when you feed it a file type it doesn't recognize.
Wait, so in my code, I could actually check for specific types of failures? Like, if it's just missing a dependency, I could prompt the user to install it rather than giving some cryptic error message?
Now you're getting it. You can wrap your conversion code in try except blocks and handle each case differently. For example, if you catch a missing dependency exception, you could automatically install the missing package or guide the user through it. For unsupported format exception, maybe suggest alternative formats. It transforms your error messages from something broke to here's exactly what went wrong and how to fix it.
This is honestly a game changer for my research pipeline. I've been manually checking why each conversion failed, but with these specific exceptions, I could build a whole automated troubleshooting system. Does MarkItDown provide details about exactly what went wrong, like which dependency is missing or why a conversion failed?
Absolutely. Each exception carries detailed information. The file conversion exception, for instance, includes the specific error message from the underlying library, the file path that caused the problem, and even suggestions for possible fixes. I've set up systems where failed conversions automatically go to a special folder with a text file explaining what went wrong. Turns a chaotic mess of failures into an organized system you can methodically address.